So I'm going to record this separately. Internet Control Message Protocol. If you remember when we were doing our OSI model, I told you that at a layer 3, there are two protocols that are very popular at layer 3. One is IP, and the other one is ICMP. These are the most important, or let me say the most popular protocol at layer 3. So this ICMP, what is this ICMP all about? Anytime we want to test for connectivity, we use a command called ping. What ping basically does is to send what you call ICMP echo request to the destination we're trying to talk about, or we're trying to talk to. So this ping operates on this protocol, or it uses this protocol called ICMP. Take for instance now, if I want to know whether I am able to connect to Google or Yahoo or what have you, I can go to my command line. I taught you guys how to go to command line and say, thank you guys, ping. Anytime you hear ping, you are trying to test for connectivity. To where? To Google, to Yahoo, to Instagram, to CNN, to whatever. And why would you want to come to this environment? For us, network engineer, this is an important tool to us at layer 3. It's an important tool because we want to be sure, okay, when we build a network, like that network that I was using to demonstrate to you guys, I want to test for connectivity. You can't just build a network and not test for connectivity. When you build a network, you test for connectivity. And how do you test for connectivity? You send echo requests waiting for echo reply. Take note of that. You send echo requests waiting for echo reply. I like to use this analogy. If you are not Ajebo, I don't know how to explain Ajebo in English here. But let's say they go farm. You used to go to farm. If I want to try to reach somebody in the farm, let's say we're in the farm together and we happen to go in different direction, I can send echo. Woo! If you can hear me wherever you are, you also reply back with echo. Woo! I know the direction where you are. So whenever one computer wants to talk to another computer, we send echo request and waiting for echo reply. Case in point, I want to see if I can reach Google. Why would I want to reach Google? Most of the time, that is how we test for connectivity. If I want to know if there's internet connection, for us network engineer, we don't just go and launch the browser and start putting CNN and all of that. Sometimes we can just go to command line and say, okay, can I reach Google? Ping www.google.com. I will hit enter. And if Google can reply, you're going to say reply from, then you see the IP address of Google and the time it takes to go and come back from Google. This is one of the things I want to analyze for you guys. I want you guys to understand. This is very important. So we use this ping command, and that ping rides on top of ICMP. And ICMP is all about, or let me say ping is all about sending echo request, waiting for echo reply. So we try to reach Google, we send echo request to google.com. And google.com is telling us this is my IP address. This is IP version 6. We're going to come to that. And it's replying back to us. So why did he send 4 replies? Because we also sent 4 echo. How did I know that? Look at this statistic here. Come down to this statistics. 4 packet was sent. Look at it up here. 4 packet was sent. 4 was received. And none was lost. That is what you always want to see, guys, whenever you are testing for connectivity. 4 packet was sent, 4 was received, none was lost. That is what you want to see. Another way we make use of this command, sometimes it's not because there is no network, but you are not sure whether the network is good or bad. But some like me that I do a lot of training, online training. I used to have 2 different networks. I still have them before I moved to Starlink. I have MTN, I have Airtel. So I will connect to MTN, I will ping. I'm going to do my research or analysis, and then I'll connect to Airtel and also ping and also do my analysis. What am I looking for? I want to see which network is strong at that point in time. How do I know the network that is strong? If I send 4 pings or 4 packets, did I get the 4 packet back? And that is not the only thing we look at. We look at the average time to go and come back. to that site. Like in my case right now, I'm having 31 milliseconds, which is very okay. Anything 100 below, it's good. But by the time you begin to test for connectivity and you are seeing 300 milliseconds, 400 milliseconds, 500 milliseconds, you know that there is a problem on that at that point in time with that network you are using. And sometimes another way we make use of ping, we do a continuous ping. If we are not sure what is happening, we don't just ping once and leave it. I can say ping www.google.com-t. By the time I hit enter right now, my computer will keep on sending message to Google and Google will keep on replying. And from here, I can do another analysis. What kind of analysis can I do here? Am I getting reply for every packet that I send to Google? And it's going to continue forever until I stop it manually. Am I getting reply for every packet that I'm sending? If from this output now, you begin to see something like, I have removed that. If you begin to see something like request timeout, request timeout, maybe out of 4 pings or 4 packets sent, you see 2 request timeout, 2 reply, 2 request timeout, 2 reply, 2 request timeout, 2 reply, 2 request timeout, 2 reply. You know that that network is erratic. That's a bad network at that point in time. That's how we make use of ping. You see now that my ping is still continuing, and you are seeing the time to go and to and from, to and fro. 21 millisecond, 30 millisecond, 21 millisecond, 30 millisecond, and there is no request timeout. So sometimes when you are suspecting a network that is misbehaving, you go to your command line and do a continuous ping. That's a continuous ping. You do a continuous ping and you begin to see from there what is the latency. Latency is the time to go and come back. 21 millisecond in my own case now. If you are getting 300, 400, 500, 1000, you know that network is not good at that point in time. And or you're getting high latency and then you are losing some package. You send 4, you got 2 reply. You send 4, you got 1 reply. You know that there is a problem. So how do I stop this? I can press Ctrl C on my laptop, on my keyboard. You Ctrl C or X. It's Ctrl C. Why is it not responding? Yeah, it's Ctrl C. Just press Ctrl C. Then that stops that. And you can now see the total number of packets I sent, 118. And I got reply for all of them. So if you are trying to test the reliability of a network, the stability of a network, you can come to this environment, use this ping to do that research. So if I out of 118 now, let's say I sent 18 packets, I got, let's say, 60 replies or 70 or 80, I know there's a problem with that network. At that point in time, I will say that network is erratic. So basically what I'm trying to communicate here is this. We use ping commands to test for connectivity. We use ping command to verify the stability of the network. We can come to this environment and see how stable that network is at that point in time. Because you can't do that. Google, when you go to browse, you just the network is slow, it's not going. Just switch to the back end, change the RAM, go to the spiritual realm and see what is going on. And from here you can see. This is one major things we do with ping. Pedro is laughing. Yes, change the RAM. You see what is going on behind the scene. Because from there you can now make an informed decision and say, there's a problem. Then you call your service provider. You snap this in and send to them. This is not acceptable. This network is erratic. This latency is not acceptable. And these things don't lie. You snap it and send to your service provider. You can do it intermittently, maybe every 2 hours. Every 2 hours, you collate them together, wire them to service. Your service provider say, I have a problem with this. Another thing you can add to this, you can add speed test. Like me, I don't know if I've showed you guys before. You go to this site, www.speedtest.net, or you can just Google speed test. There are different sites that can help you to do speed test. Speed test. Different sites. But this guy is popular here. I can click this one here, the first one here, and then I say go. What am I trying to check here? If your service provider is telling you that they are giving you 10 megabit per second, you can find out from here. And when I say you can find out from here, it's not a one-time thing. You have to be able to get the statistics. Maybe every 2 hours, you do this test. So if I click go right now, this software is going to do speed test for me and show me the available speed at this point in time. And if you are paying for a particular bandwidth, maybe 20 meg or 50 meg, even if you are going to go low, you shouldn't go lower than maybe 1 or 2 or 3, maybe 2 meg less. By the time they split the thing into 2 or 3, that's not a good network. Like one service provider that I was working with, not working as in their staff, I got internet connection for them for an NGO. So I manage the internet signal connection for the NGO. We pay for 10 meg, but we barely get 2 meg from them. So how are we going to show that we are getting only 2 meg? We continue, we do speed tests. We do speed tests different times, different days. We collate everything together, we send to them. Because these things cannot lie. Guys, this is speed you are this is the bandwidth you are giving us. We paid for 10, we are getting only 2. What's going on? Look into this. Because sometimes it's deliberate from their own hand. They want to eat their cake and have it. But sometimes it's not because it's deliberate, it's because there are some issues along the line. Maybe fiber has issue, so some packets are getting lost. As a result of that, your speed that you paid for, you are not getting it again, and so on and so forth. So there are different reasons, but you need to let your service provider know that the speed I paid for, I am not getting it. And that you can do speed test. And you don't have to do speed test only from one side. You can go to 2 or 3 different sites to do your speed test. Excuse me, this is another another side. Can this on another side. Then you compare and contrast. You collate everything and you send to them. So the margin shouldn't be too much. So at this point in time now, this is what this one is getting. If I do it again now, it may get to 200. The margin should not be too much because all of these speed tests on the net will give you almost the same range. And so with this, if your service provider knows that you know what you are doing, they will be on top of their toes. They will not want to take advantage of you. So these are things you need to understand. You need to understand this. So I am saying different things here. So when you get a reply, that means everything is successful. When you get request timeout, that means for some reason there's fire on the mountain. That message didn't get to destination. But there's even worse there's another one that is even worse than that. When you get destination unreachable, it's not just fire that is on the mountain, no. There's bomb on the mountain. When you get a message destination unreachable from your ping commands or testing, there is serious problem. And most of the time, it's always a layer 1 problem. Maybe the cable cuts, maybe the network card on the device where it is plugged to is disconnected. Anything can happen. Once you see destination unreachable, know that there's a serious problem here. But if you see request timeout, you can still get away with it. So my point is this: there are different messages you can get when you are pinging, but the one we want to see is a reply from, and you see the time to leave. Because sometimes you get reply from, not a good reply. Oh. After that, he will not tell you that what I'm trying to tell you actually is destination unreachable. It's not going to give you. It's not going to give you that. Okay, this thing won't allow me to use this pen here. It's not going to give you that time, that latency. After reply from, it will not say actually destination unreachable. That's bad news. I'm going to go to some theoretical stuff and show you. But let me just be practical. So you use ping command to test for connectivity. If the network is erratic, to check for network stability, or if the network is how do you put it, stability, yes, or reliability at that point in time. So you need to be aware of the way we use this tool. And then there's another command I want to talk about briefly. It's called traceroute. Because we are trying to go to Google. Ping will just tell you that, yeah, I got to Google and I came back. But if we do traceroute to Google, traceroute actually TraceRT. TraceRT will show you all the devices on the way to Google. When I say devices, I mean the routers. One after the other. It will be lining up all those devices and be giving you their IP addresses or their domain name as it's going. The beauty of traceroute is this. Traceroute can tell you that, okay, let me put it this way. If you ping and you have a request timeout, if ping cannot reach Google, ping will just come and say, you know what? I can't reach Google. Where did you get lost? I don't know. But traceroute will tell you. When I got to Lagos, the block road, I couldn't continue the journey. So you know that the problem is from Lagos. But ping will just tell you, I couldn't get to Google. Where did you get lost? Where did they kidnap you? I don't know. I just couldn't get to Google. I just couldn't get to Google. It will just tell you request timeout. But traceRT command will give you some, what do you call it? It will give you some clarity. I went through this location successfully. I went through another location successfully. I went through another location successfully. So look at all we got on the screen right now. These are different devices, different routers on the way to google.com. This particular site where we are now with this IP address. Because if you ping Google again later now, it will reply with another IP address. And if you decide to do trace RT to that Google address, at that point in time, you may see different set of equipment or different set of routers on the way to destination. For me, I have 8 now on the way to destination. You can have more than that, or even less than that. And if you recall, I have said this in the class before. All these big shots, Google, Facebook, and the rest of them, they have their servers all over the world. So if you are in Google now, you probably are in Google, maybe Google in Germany, Google server in Germany, or the Google server in Australia, or Google server in France, Google server in US. They will have them scattered all over the world. So when you go to Google, you can never tell which one you are going into. And those servers mirror themselves. The servers mirror themselves. Yeah, I'm recording. Thank you, Mr. Samuel. The server mirror themselves. So whatever you are doing, whatever has been done in one server is also done. Is happening in the second server, and the reason is because they don't want to be brought down by what we call denial of service attack, DOS attack, DDoS, DDoS attack, denial distributed denial of service attack, because the bad guys can overwhelm one server. So if you have only one server, they can overwhelm it. And different ways to overwhelm it. Take for instance, we were using ping right now to test for connectivity. This same ping we're using to test for connectivity. Do you know that bad guys can also use this ping to bring down a network? Same ping. They will send millions of packets and they will increase its packet size. So by the time and the server will keep on replying, and they can do distributed, maybe different devices all around the world are pinging the same server, same ping. So ping is like a two-edged sword. One side for good, one side for bad. We are using it for good things. The bad guys are also using it for the bad things. So by the time they increase the numbers of packets, and the packets are coming from different locations, and the server keeps on replying, he keeps on replying, he keeps on replying, the server CPU and RAM will get overwhelmed, it will get used up. So the legitimate user that need access to that server cannot access the server. Why? Because the server is busy replying to pings. And if they increase the packet size of the ping, it's like I want to feed you. I know that you cannot take more than the particular size of a spoon. I increase the size down 4 or 6 or 8 or 10. You're going to go overwhelmed. So that is why some servers or some websites do not respond to ping. They configure the server not to respond to ping because the bad guys can use the ping to overwhelm the server. But all this Google and the rest of them, they have multiple servers all around the world. So if you are trying to say, I will bring down Google, I will bring down Facebook, it's like you are trying to say you want to teach the ocean science. You carry a bucket and you go to the ocean and fetching the first bucket. Today I will teach you ocean science. You fetch the second bucket, third bucket. Now you go tired. So Google is ready for you. Facebook is ready for you. All of these big shots, they are ready for this kind of attack because they have their servers all over the world. So when you ping Google now, maybe you are dealing with server, the one in Germany. You send another set of ping. You are in another set of server in France. You send that. So that attack is distributed. So all the servers can handle those attacks because they spread the workload between themselves. So it's difficult to bring them down. So we are not the only one using ping, guys. The bad guys can also use ping. If you go online and do research, I think it was last year or year before, there was an attack on some websites in the world that brought down so many websites, and the ping or the attack came from some surveillance camera all around the world. And what was the problem? The people that bought those surveillance camera did not change their password, so they had default password. So the bad guys were able to log into those cameras, planted malware into those cameras, and configure them to send ping message or ping attack at a particular point in time to some servers all around the world. So by the time you have like 50, 100 surveillance cameras sending you message and you are replying to them, and you are the only one, you will get tired now. So we are not the only one using ping commands. The bad guys also, but we use ping command to test for connectivity, text for the stability of the network, and so on and so forth. But most importantly, we also use this command called tracert. So you need to know how to use both commands. You need to know how to use the tracert to see, okay, if you run into trouble, where is the problem? Where did the problem start from? Tracert will help you pinpoint where the problem starts from. If you get to the first router, second, third, fourth, and from the fifth, you can't go again. You know that the problem is from that side. Then you cannot continue your troubleshooting from that angle. So these are tools we use in the classroom. So don't ever forget these guys. So the point I'm making here majorly is this command runs on top of ICMP. That is this ping command. It runs on top. Because if you look at that chapter I'm talking about, it's just ICMP. Let's go there and see. So I like the demonstration. I want to show you one more thing and then that will be all. You see, the chapter is just ICMP, Internet Control Message Protocol. What is the big deal about ICMP? They now talk to us about ICMP message, like words. You can have different messages. Like, okay, look at what we have here. We can have ICMP version 4 and we can have ICMP version 6. I'm only talking on ICMP version 4. Look at what they said here. Internet Control Message Protocol, ICMP, provides feedback about issues related to the processing of IP packet under certain conditions. They give you feedback. You are trying to test for connectivity. They give you an idea. No, I can't reach that destination. Why? We can troubleshoot further. Oh, I can reach the destination, but before I got there, this is how long it took me. Why? We can troubleshoot further. That's the latency. Or I reached there. There were 4 of us that went to, but only 2 reached. We sent 4 packets, only 2 came back, reply came back. Why? We can do research on that. So basically, that's what the messages are all about. So the ICMP message common to both ICMP version 4 and 6 include, we use it for host reachability. We want to know if computers are reachable, or destination or service unreachable. We want to know whether time has been exceeded. What do I mean by time exceeded? Sometimes there are some devices, they will tell you that you can't reach this particular device. This particular device is beyond your reach. How? Some, maybe you've crossed more than 15 routers on the way to destination. And look at what I just explained to you guys. ICMP, that is under host reachability now. ICMP echo message can be used to test reachability of a host on an IP network. And that's what I just demonstrated to you guys. I'm sending you echo request. I am waiting for echo reply. I'm sending you echo request. I am waiting for echo reply. So when there is a problem, ICMP can return destination unreachable message to us, or it can return request timeout. Request timeout is like, you know what? I did my best, but guess what? I couldn't reach that destination. I tried. It did not work. It's left for you to now begin to do research. Begin to do research why it didn't work. And when this ICMP message is coming, if you happen to capture the packet, guys, you can see the code. They have different code. Type 0, type 1, type 2, type 3. Those codes also will give us an idea of what the problem is. Oh, is network that is unreachable, or is the host that is unreachable, or is the protocol it was blocked, or the port was something along the line. Let me show you this. Excuse me, guys. Let me show you guys this. Let's go back to our computer here. I want to ping class rep again. We did that before. And I'm going to go to simulation mode. Class rep is .2. So I'm pinging class rep. I'm in simulation mode. So the message goes here. I need to do it again. I wanted to show you guys something. Let me open this and see. Okay, let me stop it and do it again. What I wanted to show you will have passed. So I'm sending echo request. Oh no, simulation mode. I'm sending echo request to class rep. Echo request to class rep. If I open this packet right now, I need you guys to see something here. I am the, see, this is our IP header. This is layer 3, guys. This is our IP header. This is layer 3. This is source IP. I'm the one sending. Destination IP. The thing that the protocol we're dealing with at this point in time is ICMP. And what type of ICMP? Type 8. What is type 8? Echo requests. So those ICMP messages we talk about, they have different code or different types to depict or to represent the message itself. Echo request. The message this guy is sending now, capture it along the line. We know that this one is echo request. Type 8 is echo request. So every other thing is intact. Layer 2 is intact. Source IP address, destination MAC address is intact. Layer 3 is intact. Source IP address, destination MAC address is intact. Let's now see how the class rep will respond back. So the message goes to the switch. Of course, you guys know this. The switch will send the message to the class rep. Now let me click the same envelope. Class rep need to respond back. Class rep is responding back with ICMP message type 0. Type 0 is echo reply. You don't need to cram all of these ones. I'm just trying to prove a point to you guys that ICMP messages have different types, different codes to depict the message. Echo request, echo reply, destination unreachable, all kinds of stuff. But you don't need to go into all of those details. You just need to know the basics. And the basics are, we send echo request, we get echo reply. If we don't get echo reply, what do we get sometimes? Most of the times, we get request timeout, which is still okay. I'm not saying it's okay. We can work around it and find out why. And once you get destination unreachable, you know that there's a problem. Let's ping an address that does not exist and see what packet result will show us. I believe this one is taken care of. Let me ping an IP address that does not exist. I don't have .5 here on this network. Let me ping .5. The thing will try and try and try and come down to you. If it's on the live network, it will tell you destination unreachable. Destination reachable will simply mean I have no idea of anybody like this on our network. But unfortunately, packet tracer shows us request type out because nobody has this IP address in this network. I don't have anybody with .5. Fine, let me do something. Let me take 2.2. So when you see destination unreachable, it's either is a layer 1 device issue. The cable is disconnected, or the network card has gone bad. The computer is not feeling, it does not even have an idea of how to reach that particular IP address. So it's a critical situation whenever you see something like that. So request timeout is a problem for us, and we can solve the problem. And you can see what I was trying to say earlier. The guy sent 4 packets. The guy did not respond with any. How many packets were lost? 4. Our percentage loss, 100%. No response from that IP address. Not that I didn't try to reach the IP address. I tried, I sent my echo, but nobody responded to that IP address. So you need to understand this, guys. So we use ping command. which is based on ICMP, echo request, waiting for echo reply. And sometimes we don't get that reply. We get request timeout. Sometimes we don't get request timeout. We get destination unreachable. These are some concepts that I want to pass across. So that chapter is just basically talking about ping, ICMP, and that is based on ping. So they talk about ping, and then they talk about what is it called? Trace route command. So any question, guys?